Welcome to Ask and Learn.
In a hospital, pure oxygen may be delivered at 50 psi, gauge pressure, and mixed with N2O. What volume of oxygen at 20 degrees C, 50 psi, should be mixed with 1.7 kilograms of N2O to get a 50-50 mixture by volume at 20 degrees C. So with this problem, kind of given a lot of information, but we basically, I think we just need to find the volume of N2O that we have and just say like that has to be the volume of oxygen. So great. So as far as N2O goes, or actually let's just start by writing down the givens. So mass of the N2O is 1.7 kilograms and the temperature is 20 degrees Celsius and P gauge is 50 psi. Okay, and so basically we wanted to use the ideal gas law. PV is nRT, solve for volume, get volume is nRT over P, and just say that's how much oxygen that we need. So the main challenge maybe is kind of converting all of these to the units that the ideal gas law sort of demands. So we need kilograms to moles, temperature to Kelvin, so degrees Celsius to Kelvin, and pressure to pascals. And we also have to use the absolute pressure anytime we're using the ideal gas law. So gauge pressure is simply just the absolute pressure minus the atmospheric pressure, because in a lot of problems, I think you just end up like subtracting off the atmospheric pressure. So that's kind of the spirit of why you want to make a gauge pressure. A lot of students are often confused by that. So let's just go ahead with the unit conversions. Actually not equals. So we want to just multiply by the molar mass. So I looked it up and it's times 1 mole per 0.044 kilograms, and the kilograms cancel. And let's see, I'm going to do this calculation real quick. So that's 1.7 divided by 0.044. Great. And you got 38.6 moles. I originally did it slightly differently, so I just wanted to double check my calculation. 38.6 moles. Wonderful. And then this is, you always add 273.15 to the degrees Celsius to get the temperature in Kelvin. So that's going to be 293.15 Kelvin. And then, okay, P gauge. First, let's just convert this to pascals. So my friend on Google told me that it's 6895 pascals per psi. And let's see what you get with that. Um, 3.45 times 10 to the 5th pascals. Okay, let me write that. Oops. Equals, oh, not volume, sorry. 3.45 times 10 to the 5 pascals. And then you need P absolute, so that's P gauge plus the atmospheric pressure. So that's 3.45 times 10 cubed plus 1.03. Oh, not cubed, fifth. What a big number. Okay, that 5 looks ugly. Let's erase it and make it look nice. Okay. 3 times 10 to the 5th pascals. And let's figure out what that number is. .46. Times 10 to the 5 pascals. So like 4 times atmospheric pressure. All right, so I think we have all our ingredients now. We're not going to be doing any clumsy unit conversions in the equation, which is kind of what I normally do, but this would have been kind of hectic if I had chosen to do that. So here we go. 38.6 moles. I'm going to run out of room even if I do that. Okay. Okay, 38.6 moles times 8.31 joules per mole Kelvin times 293.15 Kelvin, all divided by this huge pressure, 4.46 times 10 to the 5 pascals. And if you plug that onto a calculator, you will hopefully obtain that the volume is 0.21 meter cubed. Boom.